So I'm going to complete the square for our parabola unit. And the first thing I want you to notice is that I need to get one of the variables off by itself. So I'm going to focus on the y because the rest of the equation I have the x's being squared. So first thing I'm going to do is I'm going to move that the one variable that is nothing like the others, think of it that way, off to the side. So if I do that, I end up getting 3x squared minus 12x plus 15 equals y. And now what I want to do is let me change my pen here. So now what I'm going to focus on is I'm going to focus on just the x's here, and I'm going to complete the square for this unit. This 15 that's off by itself, we're just going to kind of leave that off on its own for now. So what I want to do is if my x squareds have a GCF or a leading coefficient, I need to factor that out first. So if I factor that out, I get 3, and then I get x squared minus 4x, I'm going to leave a little bit of space, plus 15 equals y. So all I did was factor out the GCF out of just the x terms. Now if you remember, we're going to take half of b, so it's b over 2, and then we square it. So my b term happens to be negative 4. So negative 4, I'm going to write this out, so negative 4 divided by 2 squared, well half of negative 4 is negative 2, and negative 2 squared is a positive 4. So I'm going to add a 4 to this into that parenthesis. But this is the trickiest part of this whole unit. Let me change this. So if I if I add a 4 to this side of the equation, can you see that I am really adding 12 to this side of the equation? So I really offset my equation not simply by 4 but by 12 because I have to multiply, I have to FOIL that out. 3 times 4 is 12. So it is legitimate to also at the same time subtract 12 from the same side of the equation. In the past what we have done is we have said that if you add 12 to this side of the equation, you need to add 12 to this side of the equation. That keeps your two sides balanced. But if I subtract 12 over here, then remember I need to keep this y by itself, so I'm eventually going to have to, if I add 12 to this side, I'm eventually going to have to subtract it. So let's not go through that process. So can you see that, this whole thing is about keeping an equation, anything with an equal sign is an equation, keeping it balanced. And if I suddenly, insert a positive 12 into one side of the equation, and then at the same time I subtract 12, well, that's a net difference of 0. So I'm really not offsetting the balance of that equation by doing both of these at the same time. So if you add, so I got 3 times 4, which is positive 12, and I subtracted 12 at the same time. So now I'm going to get 3, and now this I can complete the square on this, right? Or I can square it out rather. So this is simply going to be, x minus 2 squared. So where did that come from? Well, that came from, two numbers that multiply to be positive 4 that add up to be negative 4. Well, negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. And then I have to put these two guys together. These were the numbers that, remember I said that I'm just going to hold off to the side. So positive 15 minus 12 is simply a positive 3, and that equals y. So now we are ready to graph this parabola. Now we are in vertex form. My vertex is on positive 2, positive 3, and my 1 over 4 p-value equals 3, so I could find that p-value and find the focus and the directrix. So in this second example, I already have my y set off by itself, so all I need to do is focus on completing the square for the x's. So if I have a leading coefficient, I need to factor that out, so that's going to be, just 4. So then I have x squared plus 6x, I'm going to leave a little space and then put plus 10 equals y. So all I did so far was factor out the GCF. Now what I'm going to do is I'm going to take half of b. So here's my b term. I'm going to take half of it, so that's 3. And then 3 squared is 9. So I'm going to add 9 to this part of the equation. Okay, so when I add 9, I am really adding more than 9 because I have to factor this or FOIL this out, right? So I'm really adding 36 to this side. So at the same time, I need to subtract 36. Right? Because remember, now we're going to do the positive and negative. I don't want to offset my equation. I don't want to change the value or the equality of my equation. So adding and subtracting the same number at the same time doesn't change that equality. So now I have So this now factors very nicely. This is just going to be x plus 3 squared, right? Two numbers that multiply to be positive 9 that add up to be positive 6 is just 3. Oops, I forgot my parenthesis. And then I just need to combine these two terms right here. So this is going to be minus 26. So my vertex, equals y. So my vertex is very easy, negative 3, negative 26, and my 1 over 4 p-value equals 4, and I could solve for p. So let's look at the next example. Okay, so in this example, now I have my x by itself, so I changed it up a little bit on you, and I'm just going to factor out a GCF here. So I get 2y squared plus 8y, leave a little space, plus 6 equals x. And now I'm going to add half of my b value, so half of 8 is 4, and 4 squared is 16. So I'm going to add 16, but remember, I'm really adding more than 16. I'm really adding a 32, so I want to subtract a 32 at the same time. So now if I rewrite this, I get y plus 4 squared, and then I have to combine these two guys, and that is, what is that? What is 6 minus 32? That's going to be negative 26, right? Yeah, equals x. So this vertex, in this example, is now going to be negative 4, negative 26, but remember this parabola, well, this a value is positive, so just remember this parabola is going off on its side, so negative 4, negative 26 is going to be like way down here somewhere.